No sound detected. Hopefully you can hear me now. Hopefully you can hear me now. Hello, hello, hello. Just looking at this and what we're doing. Oh, sorry. Today is September. Okay. Hello, everybody. We're going to be reading the Abacus. So let's do a little bit of reading. Let's do a little bit of reading. So anytime the beads are touching this horizontal bar, this is the horizontal bar. When it's touching the horizontal bar, the beads, these are the beads. Beads, these are beads. So if it touches the horizontal bar, this is being counted. So we have 1, 2, 3, 4. We have the value of 5, we have 6, and then 7, 8, and then 9. So then we have 10. That's what 10 looks like. Hello, everybody. Hello. Wow. Amazing. So many people. There's so many people. Hello, everybody. Hello, hello, hello. Good. Hello. Just hello. If you have, if you're, keep your mind open for something different. Keep your mind open for something different. What are we gonna do? Open your mind. Open your mind. Hello.
Now, open your mind to me, please. Open your mind.
Thank you so much for liking the live. Okay, we're going to start over. Let's do a little review. And then we're going to start going into this Abacus maze that I have. This Abacus maze is available in my TikTok shop for those of you that are interested. I have it here and I pinned it. So what we're going to do is we're going to understand how to read the Abacus. We're going to do 1, 2, 3, 4. When the beads are touching this horizontal bar, this is what's being counted. So after 4, we have 5. The top bead will always be 5. When we look, we have 1 here, right? 1 plus 5 is equal to 6. Do you see that? If I did 2, 1, 2 plus 5 is equal to 7. I have 3, 1, 2, 3. 3 plus 5 is equal to 8. And then we have 4. 4. 1, 2, 3, 4 plus 5 is equal to 9. So that's how we're going to be counting. That's all we're doing. So guess what? Well, what's after 9? 10. After 9 is 10. What happens? That's what 10 looks like. 10 looks like that. Why? Because every column has a place value. So here's our place values, right? We're going to be doing this. So we're going to do the ones, the tens, the hundreds, the thousands, and the 10,000s. If you notice, I have a dot right here. This dot tells me it's the ones place, and then I put it down here. This one is telling me that this is the thousands place, so I have a comma right there. And then notice after the ones will be our tenths and our tenths and our hundredths. There we go. All right. So for those of you just joining, thank you for joining. Thank you for joining. We are going to be working with this maze. And I want to work on this maze. I am here to chew some bubblegum and kick some butt. And I'm all out of bubblegum. For those of you that just joined, thank you so much for joining. Thank you so much for joining. My number is... What is my number? So I have my tens and I have my ones. I have my tens and I have my ones. What number do you think this is? Anytime the beads are touching this horizontal bar. Hello, LMGS. Hello, LMGS. It's been a little bit. How you been? How you been? Welcome, 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 welcome. Well, I have too many. Now I have too many. Welcome. Where's my welcome? Welcome. Oh, I've lost it. No, it's got to be here. It's got to be here. Welcome. Where's my welcome? Oh, there it is.
Welcome to the real world.
Oh my God. Hello, Allie. Hello. You're not on live? Yes, thank you. It is 15. Hello, everybody. Hello, hello, hello. Yes, it is 15, and we're going to do 15 over here, and then we go over here. There we go. So we have our next number. We have our tens and our ones. We have our tens and we have our ones. What number do we think that is? So remember, all the bottom beads a value of 1, and then all the top beads a value of 5. Because this is not touching the horizontal bar, this number is our ones and our tens. What number do you think this is? If we have 1, 1, 1, 1, this is 4 ones. If we have 2, 1, 1, this is 2 ones. It is. I'm not. No, I was supposed to go to the gym, but instead I made a skit. Ha ha ha! You should still go to the gym. I didn't get a chance to go for a run today. I was a little too busy with all these meetings, but you should go to the gym. You should go to the gym. Totally go to the gym. Go to the gym to go get your dopamine. Yes, thank you, LMGS. Yes, it is 20. It is 4. So when we're looking, we have our tens. This are our tens. This are our ones. We have 1, 1, 1, 1. This is 4 ones. 1, 2, 3, 4. And this is 2 ones. 1, 1. You should go. You should go. Go to the gym. Go to the gym. It's still early for you. You should go to the gym. Go to the gym. All right. So how are we doing? We have our next number. We have our tens, and we have our ones. Guess what? Now we have the top bead. The top bead is a value of 5, and it's touching this horizontal bar. We have the two bottom beads, and it's touching the horizontal bar. So we have but it's 9. No, it's not. So? You're not that old. You can go to the gym for like a half an hour. It'll be fine. You go to bed at 10:30. You'll be refreshed. I have to wake up early. What? You know what? Do some jumping jacks. 72? Yes, thank you. Thank you. Yes, it is 70. It is 2. Do some jumping jacks at least. Do some sit-ups or whatever. Do some squats. There we go. Do some squats. You don't have to go to the gym. You can do it all at home. You can do body squats. So yes, thank you. Thank you. It is 72. So we have our ones. We have our tens and we have our ones. Remember, the top bead is a value of 5 and the bottom bead is a value of 1. Together, they are this number. So, okay, I'll do a whole, do a whole workout. There you go. There you go. Well done. Yes, it is 16. It is 1 and it is 6. Thank you. Yes, welcome, welcome, welcome. Yes, so all the bottom beads is a value of 1, right? This is 1, this is 1. But because we have the top bead touching, this is now considered 16. 6. This is considered 6. Because we have a number here, this is the 10. So how do I know? I know because every column is a place value. We have our 1s and we have our 10s. We have our 1s, we have our 10s. So this becomes 1 and a 6, right? And so that takes it to 16, and then we on to our next number. Next number! Okay, we have our next number. Can I read it? I can read it. My eyes are not that old. So we have our 10s, and we have our 1s. This is easy. How easy is this? This is an abacus, and abacus is to visualize your numbers. Yes, thank you. There's 30 and there's 4. Really, do you really need a question mark? Because you know these numbers. You know these numbers, right? 1, 2, 3, 1, 1, 1, 1, 2, 3, 4, 1, 1, 1, 1. These are 1s and these are 10s. Yes, 34. Thank you. I don't even know. It's like 17. I don't know that. I don't know. Is that night? Is it supposed to be night? I don't know. I can't decipher that. My brain can't wrap around your username. I want to call your name, but I don't know what it is. Hello, Shadow. Oh, it is night. Oh, you use a 7 instead of an 8. Ah, interesting. Ah, okay. Okay. So my first guess was right. Thank you. Thank you. Hello, try your best. Hello, Shadow. Welcome, 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 welcome. Welcome, everybody.
Welcome to the real world.
So we have our number. We have our 10s and we have our 1s. We have the top bead is a value of 5 and we have a 1, 1, 1. So there's 3 1s. So yes, thank you, LMGS. It is. Thank you so much for checking in. Try your best. Thank you so much for checking in. For those of you that are interested, go ahead and if you want to join my community, my orange heart me is right around somewhere where my head is. Go ahead and click on that to join my community. Thank you so much. Welcome, welcome, welcome. So yes, thank you, Knight, and thank you, LMGS. We have 88. The top bead is a value of 5. The bottom bead is a value of 3. 1, 2, 3. The bottom bead is a value of 1. We have 3 1s. 1, 1, 1. 5 plus 3 is 8. 5 plus 3 is 8. Thank you, everybody, for joining. The number is 88. So we're only doing 2-digit numbers right now, and we're going to understand how to read the abacus. After that, we're going to do some adding, and you can do subtraction, multiplying, and dividing on the abacus. But for right now, why is it? Oh, Bubba, that's a good question. That's a good question. Oh, maybe I should just whisper all the time. I don't know why people do that. Okay, yes. So if you notice there's a label right here, this label right here, that labels my ones place. So because I have my ones, and after the ones is my decimals. We have our tenths and our hundredths. Does that make sense, Bubba? Thank you so much. Yes. Is it the same on the other side too? No. This one here is the thousands. This one is like a comma, right? So when we're looking, I need to find my paper. I need to find my paper. Right. Okay, wait, hold on. I need to, oh, here it is. So just like this number right here, this handy dandy number that I have, here we go. So you could have it without the comma, right? It's kind of difficult to see. However, if I had it like this and I had my ones, this would be my thousands, like the comma. So it's 3,000. There we go. It'd be 400, and then be 50, and then 6. There we go. Does that make sense? Hello, JJ. Thank you for that question. See, that's what I'm saying. Please, if you have any specific questions about the abacus, I am very happy to explain it. Thank you. Hi, JJ. Got wings up. That's fantastic. That's fantastic. So we're going to continue on with this concept, right? So if you look, we have 73,000. 73,000 with the comma. There's my comma, right? We have 73,456.25. There we go. There we go. Guess what? Guess what? Guess what? So if we had this number here. Do you know what this one would be? It'd be like this.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So we have 55,000, right? 55,555.55. And that's what that would be, right? And we could do a whole row of 5s. We could do a whole row of 6, right? We could do a whole row of 8s. Guess what? 9s. What do you think that would be? Let me know. What do you think that would be?
99 problems, but a ain't one. If you having girl problems, I feel bad for you, son. I got 99 problems, but a ain't one. Hit me.
This would be 99,999.99. That's what that would be. So when we're looking, all the digits, all the columns has a value of every number. We only have 10 numbers. If you really think about it, there's only 10 numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the 10 numbers. And so this is actually a decimal system, it's not a base 5 system, it's a base 10 system. Just like how we write, we have numbers from 0 to 9. 0 is our I love the music of the education. Thank you. Thank you. I appreciate that. I appreciate that. Wait till I get some trolls and you're going to hear something better. Okay, so thank you everybody for joining. Thank you everybody for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
Okay, so here's that trivia question. Where do you think that one came from? All right. So if I choose this one to be my ones place, or I could choose this one to be my ones place. Guess what? If I choose this one to be my ones place, right, then I can have this number right here. This would be 0, right? This would be my ones place. Why? Just like a Pokemon, you just need to choose one. Just choose one.
Pokemon, I choose you.
So instead of choosing this one to be my ones, I choose this one to be my ones. If I choose this to be my ones, then I do 0.00001. That's what it'd be. And then we can continue on with the concept of understanding how to read the numbers. We can go by Roman numerals. So with the Roman numerals, if I do 1, that's 1. This is 2, that's 2. This is 3, this is 3. This is 4, well, that's 4. That's a little bit different, right? We have 5, the top bit is a value of 5, and then we have 6. 6 is 5 plus 1 is 6, 5 plus 1 is 6. We have 7, we have 5 plus 2 is 7, 5 plus 2 is 7. We have 8, 5 plus 3 is 8, 5 plus 3 is 8, and then we have 9. 5 plus 4 is 9. Now what's 10? Again, 10 is a 0 and a 1. Now it's a two digit, right? So when we're looking, that is what it is. We can do it again with the tally marks. We could do 1. I'm going to start from here. So then I decide to choose, instead of this one to be my ones place, I'll choose this one to be my ones place.
Okay, Charizard, I choose you.
So then if I choose this one to be my ones place, right, like a Pokemon, just choose this one. I'd be 1, 2 tally marks, 3 tally marks, 4 tally marks. Then we have 5 tally marks. The 5 is like a slash. The 5 is a slash just like the top beat up here. We have the slash with the plus 1. That's what it is. We have a slash with a plus 2. That's what it is, right? 5 plus 2 is equal to 7. We have 5 plus 3, right? 5 plus 3 is equal to 8, and then 5 plus 9. 5 plus 4 is equal to 9. So now we understand that after the 9, again, it starts over. That would be 10. So it doesn't matter where you are. You just got to keep track of your columns. That's all it is. So, Knight said it was 79. Is it 79? Oh, yeah, it is 79. Thank you, Knight. Yes, it is 79. So when we're looking here, the question is, now it makes more sense, right? 79. So we have a 70. Thank you, Knight. We have 7. The top bead is a value of 5. The 2 beads are the value of 1. Together, this makes 2. 5 plus 2 is equal to 7. And then 5 plus 4 is equal to 9. Yes, thank you, thank you, thank you. So then we have our next number. This is the maze. We're just following the maze, and we have this number. This is easy. What number do you think this is? We have that number. That number is only what? It is only the top bead. What number do you think that is? It is...
Bueller. 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 Bueller.
Thank you, Jay Sturdy. It is. It is 50, right, at 5 and a 0. When we're looking, right, gaming goat, you don't forget the 0, because then your paycheck would be very small. If you had less zeros at the back, you're not going to have a very big paycheck. So you want to remember that there's a 0 here. This is the 1s, this is the 10s. But that's a very good guess, because this is a value of 5. The top bead is a value of 5. So I'm not sure, Julian, what you're talking about, because apparently you're not understanding.
Do you understand the words that are coming out of my mouth?
Do you understand the words that are coming out from my mouth?
So when we're looking, this is actually the value of the 5, right? The top bead is a value of 5, and it's touching this horizontal bar. So we have as 5 and we have as 0. We have the bottom beads that are not touching, so they are not being counted. So this would be 50. Thank you, Jay Sturdy. That is exactly what it is. So 50 looks like this. 50 looks like that. I'm just going to color it in nicely, right? And there we go. And then we have our next number. We have our next number. What number do you think this is? We have our 10s. We have our 10s and our 1s. What number do you think that is? What number do you think it is? If the top bead is a value of 5 and it's touching the bottom beads, right? We have 2 bottom beads and 1 top bead. What's that number? For those of you that are here and have been here for a little bit, let me know what number you think this is. Thank you. Is it 37? Yes, thank you, Jay. Yes, thank you, Jay Sturdy. It is 30. It is 7. We have 3, 1, 2, 3, and it is 7. Thank you, Bubba. Thank you. Try your best. We have 5. We have 2. 5 plus 2 is equal to 7. Thank you. It is absolutely correct that a number is 37, and we have our next number. So we have our next number. What number do you think this is? We have our 10s. We have our 10s and we have our 1s. So we look at it. We have our 10s and we have our 1s. What number do you think that is? Thank you, Nat. Yes, thank you, Nat. Thank you, Bubba. Thank you, Jay Sturdy. Yes, it is 27. Because we have 2 here, 1, 1, that's 2, and then 1, 1, but don't forget we add the 5. If we did this, this would be 22. You add the 5, this is 27. Does that make sense? So this will give me the 27, and I have my next number. We are almost done. So we have our 10s and we have our 1s. We have our 10s and we have our 1s. What number do we think that is? Thank you, everybody, for joining. Thank you, everybody, for joining. Please let me know if you have any Abacus questions you would like me to answer, anything you like. We are still in the beginning stages, and if you're confused now, we will not be able to continue on. So please, right? Oh yeah, you're totally getting it. You're totally getting it. Thank you, Jay Sturdy. It is. It is 80. It is 7. We have the top bead as a value of 5, right? These top beads are touching this horizontal bar, so they're being counted. And then we have 3. 1, 2, 3. That's how you get 80, right? 5 plus 3 is equal to 8. That's how you get 7. 5 plus 2 is equal to 7. So when we're looking, we have 87. Well done, well done, well done. So then, whoa, we have our final answer. I don't know. There we go. We have our final answer. What is our final answer? I should remove that. I'll do that in a little bit. What is our final answer? We have our 10s and we have our 1s. What is our last number? Yes, it is. Thank you. It is not 19. This would be 19, Nat, because it would be the 1 at the bottom. But what we're doing is actually the 1 on the top. Right? Thank you. Have a good night. Try your best. Have a good night. I'll see you in my next live. Does that make sense, Nat? So when we're looking at the 10 bead, the top bead is touching. Yep. Yeah. It's one of those slight differences, which is very interesting. But what we're looking for is the positioning of the beads. When the top bead is touching, it's always going to be a value of 5. Yes. This is like bragging rights. What did I do last night? I learned to read the Abacus. Hello, Edric. Hello, Edric. How you doing? How you doing? You know, funny. It was one of those. Was it one of those things that you wanted to learn in 2025? Is learn how to read the Abacus, Bubba? But here we are. So thank you so much for joining. Thank you everybody for joining. Welcome everybody. Welcome. What are your plans for today? These are my plans. My plans is...
James, mate, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
So, since the 90s, oh my goodness. So this one right here is my Abacus book. This Abacus book is my Abacus maze. What we're doing is we're learning how to read the numbers, and we want to do is we understand how to read the tens and the ones. I do a review on what the Abacus is. We first start talking about like what the numbers are on the Abacus, and then I tell you like the description, like 2 beads on the bottom, and that's what's being counted. Then we have a review on what a 2-digit number looks like. So a 2-digit number is what a 2-digit number is. So we have our tens and we have our ones, and then we start with the mazes. I give you a whole bunch of mazes that you can go through and you try to figure out, the idea is you color in the numbers and then you have to find out where the path is. And so that's why I actually give you this thing called a mask maze. But I do notice that the mask maze is a little bit thin. The paper's a little bit thin. So you have the opportunity to download it at your leisure, to be able to download it and print it out on a thicker piece of paper. The reason why the thicker piece of paper is nice is because then you cannot see through the paper. And guess what? You can't cheat. There's no cheating. Actually, it's really difficult to cheat from another person for another person. So anyways, thank you, greatness. Do addition. Oh, do addition. Hello. Yes, we will get into that in a little bit. So we're after the doing the mask, after the doing this way, we have the next way. The next way is called reverse maze. The reverse maze means that I give you the path and I give you the number, and then you're going to color in what the number is. So this is 8, you're going to color in 8. And that's what it is. And if you're ever wondering, I do have answers in the back of the book for those of you that just want to be sure that you're on the right path. But yeah, we have those answers, and then that's what it is. So this book is available in my TikTok shop. You do have the ability to buy it with an abacus or without an abacus. It comes with this abacus or it comes without an abacus. It is up to you. So next we're going to do, if we know how to read, we will know how to move the beads. 2 digits. Yes. Is there a bundle deal? Well, what kind of bundle? Are you talking about the mazes with the everything else, or what sort of bundles are you talking about? I do have one bundle called the first grade bundle, where it's this one, and then there are 3-digit maze, and then it comes with the other books like the plus the 5, minus the 5, plus the 10, minus the 10, and the abacus formula. It comes with that. Hello, Danny. So those are that would be one bundle. But if you're looking for the preschool one, I do have that one available as well. The preschool one means that we'll have everything. So it'd be the preschool book. It comes with the abacus formula book. It comes with the minus the 10, plus the 10, minus the 5, and then plus the 5. Those are the only books that would be. How much? Which one? The preschool one? The preschool one is 109, 107, 102, 102.99. That's the preschool one. That's the one. I finally got it in stock. So thank you so much for joining. Yes. Hello, Danny. Hello. I was trying to figure out my whole inventory stuff. Okay, we're going to continue on. Thank you so much for asking. I've got books. These are all my books. I've got books. And then, And then if you're ever wondering, if you want to learn it on your own and you think this is too kitty for you, I do have one for Abacus for adults. Hello, Board. Yes, thank you. It is 9:50. Thank you so much, Board. I hope you're doing well. You're not too nervous for school. Thank you for checking in. Thank you for checking in. For those of you that are interested, go ahead and check in. We're on the orange heart me, and we're right around where my head is. Hey, have you seen the other stickers? Do you see the other stickers? So, for those of you that are interested, I do have this book. This is a Abacus for adults, and what it is it's not the individual ones. You do have the option to buy it with either a small abacus, without an abacus, with an abacus, or with a 13 column abacus, because size matters. Why? Because it's bigger. This is a 7 column abacus. This is a 13 column abacus. You can have a choice, either or. This book itself is my book. These are all my books, and these books are all very abacus focused. And again, what we're doing is we're learning how to read the abacus. I give you the maze. I decided to use the abacus in class to help me calculate. I came across that I couldn't do. Uh-oh. That's because you don't know your formulas. That's why. So it comes with the reverse maze and so forth. And then this is more of like a summary. It goes a little bit faster. Hold on. It goes a little bit faster. And so we go into, and then we start going to the concepts. The concept is how to add the 5, then you minus the 5, and then there's these activities to strengthen the concept of adding in the 5 and taking away the 5. And then I give you the summary, and then we start going into another concept called adding the 10. Adding the 10 is like carrying over and borrowing in mainstream math. And so when we're looking at it, Danny, you're going to are you being filtered? Because I don't see the question. We have repeated addition, which is another form of multiplication on the abacus. So repeated addition, and I ask you to write the formula because I want to strengthen that concept of the formula. The formula is a very critical, a very fundamental piece in the abacus world. And so, to rule the world, yes, Raider Nation! Yes.
Gee, Ray, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
What is an abacus? An abacus is a math tool that will allow you to visualize your numbers. Thank you, Raider Nation, for the rose. Thank you for the rose. 4316. Okay, that's a minus. Okay. Let me put that pin in that, and we will go into it. All right? So let me finish what my little review is. I just did 4 hours of work. Oh, bored. Your life is so hard. Come on. 4 hours of homework is nothing. Wait till you have to go like 8 hours, 10 hours of working. That is be a problem. Not to distract, but that's a dinosaur on your lamp behind you. Yes, it is. And love your books on display. Thank you so much. Thank you so much. Those are my books. Yep. Those are all my books. And yep, those are my, yep. Thank you. Thank you. I appreciate that. This is the adding of the 10, and then we minus the 10, and then I give you some activities to do color by number, and I go into doing more number bonds. Here is the summary, and then I give you another activity. And then this is inside the adult book. So I was thinking to make it a little bit more fun and more interactive instead of just a bunch of monotonous numbers. So this is the framework that we're going to actually go through. This framework is going to be very critical when we do this right here, but I'll tell you in a little bit. And then we continue on. This is what we call a two-step equation. That means you need to really understand how to make a 5 and how to make a 10, which is the core concepts of adding and subtracting. Once you understand that, then you can go into learning how to do the adding. And then you have the puzzles. You answer the puzzles. You find the answer pieces. And then you write the formula. So it seems intimidating. It's actually not. I take you step by step. This is all step by step. If you're looking for something slower, you can do the individual books. The individual books is these ones. And we'll go into that. So we go plus 5, minus 5, plus 10, minus 10. Sorry, board, but 4 hours of homework is okay. Wait till you get into college. Then you'll be really tough. You'll be learning. That's okay. You'll be fine. It'll be good. It's only the first day, second day of school, third day of school. You'll be fine. You'll be fine. So again, we do repeated addition. In an abacus world, we only go from up to the 9 times table, right? We only go up to the 9 times table, and then after that we go into minus the two-step equation, and then again there's the puzzle pieces. We answer the questions and you find the answers, right? And then there's the mosaic. There is no key. So it's up to you to color it in if you like. I do give you option to write the formula, but it would be recommended to write the formulas. That's why I give you space. And so the idea is to continue on understanding how to use the formulas, because once it becomes automatic, then you'll be able to add and subtract at anything. So then I give you hidden words, addition mazes, more ladder words, and so forth. And then that's it. This is my whole book. And I give you a bunch of other times to do it. That's really awesome. Thank you so much, Bubba. Thank you so much. So, and I also have answers in the back of the book, just in case you were wondering. I do have answers in the back of the book. Oh, that was the other thing. There's this pixel art. This pixel art is kind of cool. But the thing is, it's like the answers are, the questions are super simple. If you look at it, it's super simple. You could do it in your head. I know you could do it in your head. But guess what? I want you to do it on the abacus. The reason why is so then you could see how the beads move. So I have 9 on the abacus. I have 9 on the abacus. I have 9 on the abacus. I want to take away the 5. To take away the 5, I just need to move it up like that. That's all I got to do. That's what taking away 5. So then you see your answer is 4. So the idea is to do the problem, right? Because if you don't do the problem, then you don't see how the beads move. So the idea is to learn how the beads move. Pug on a perk. Did I answer your question? A, Abacus is a counting tool. It is a math tool that helps you visualize your numbers. So now we're going to do the question. I'm thinking about doing it now or doing a little bit. Okay, we'll do it now and then we'll come back. Okay, don't be intimidated by this question. The only reason why is because it's kind of more of an intermediate question. There's a few things that you need to understand, but I'm going to just push everything over. Now, please. Oh, no. So just so you know, it is a little bit advanced. Let me see if I can walk you through it as much as I can. All right. Where is Danny? Are you still around? So we have 43 on the abacus. That's easy, right? Not a problem. And then what we're going to do is we're going to take away the 4. We're going to take away the 16. When we take away the 16, we do the first number on the left first. We actually go from left to right. That's how we do it in Abacus World. We go from left all the way to the right. So we start off with this one. So we take away the 1. That's easy. Not a problem. We take away the 1. Now what? Now we got to figure out how to take away the 6. Take away the 6 is a fact family, using a fact family of 10. We know how to make a 10 with a 5, with a 4, right? 6 minus the 6 minus the 4 equals minus the 10. So what do we do here? We need to minus the 6. What is the formula to minus the 6, Danny? Minus the 6 is equal to minus the 4. No, minus the 10 plus the 4. Take away the 10. Taking away the 10 goes where? Take away the 10 goes over here. So we minus the 10 and we plus the 4. When we add the 4, is there room to add the 4? There's no more room to add the 4. What do we do? Well, what do we do? If remember, if I have, no, yeah, I want to add the 4. We have 3 on the abacus, I want to add the 4. We have 3 on the abacus, I want to add the 4. I'm adding the 4. Why? That's one of the formulas. It's a little bit more advanced. We know that we're going to round to 5. I don't know if you can see that. We're going to round to 5. We got to take the 4, we round it to 5. What are we going to do? We got to plus the 1. We got to take away the 1 from the 3. Take away 1 from the 3, and then make our 5. Our 5 is made, so we just add the 5. So our final answer is 27. It's a 2-step equation. Thank you. Yes, thank you. It is minus the 5 plus the 1. It is a 2-step equation. This two-step equation is why? Because this one right here is what we need to do. We need to do a plus 4 is equal to plus the 5 minus the 1. So that was a little bit advanced. Thank you everybody for joining. Let's break it down. So the first thing we need to do is understand how to make a 5. That's the first step. And it comes in stages, right? What we're going to do is we're not going to memorize. We're not going to memorize our doubles. Two-step equation is getting me. Yes, and that's why I made this book. I made this book specifically so we can talk about the two-step equations. And I'm making another book for the kids to do the two-step equations. So, that's what this book is. We are going to go into the next book. No, we're going to go into the beginner book. The beginner book is the preschool one. So we're going to do the preschool one. And we're going to learn how to move the beads. We're going to take a couple steps back. So thank you everybody for joining. Thank you everybody for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
So let's do a flip through in this book. This book is available in my TikTok shop. What we're doing is we're learning how to read the numbers. That's all we're doing. I gotta find my book. It's right here. All right. So when we look at it, all we're doing is who's it for? It's usually for kids that are 3, 4, and 5. And so the idea is that we're just learning to teach them how to read the abacus, how to read their numbers with an abacus. That's all we're doing. And so I just give you activities on how to read the abacus and what it is with the numbers. The idea here was just to get comfortable with the numbers and how to read it on the abacus. And I give you the activities. There's some pixel art. There's accounting. And then we start breaking into the how to go from 5 to 9. And so what I do is I just explain how the 5 and the 7 and the 9 goes. And then we start talking about the numbers and do activities. That's what this is. And then what's after that? We count forward, right? After counting forward, we count backwards. After counting backwards, we have to count what comes in between. So if I give you the number here and I give you the number here, I want to know what the number is in between. And then we count what comes surrounding. So if I give you the number in the middle, you need to tell me what the number is in the surrounding. So this is more about the relationship of the numbers and just understanding what those things are. And then we have the bigger than and less than, and then we start going into moving the beads. So here we are of understanding how to add. When we're adding, we want to look at the second number. We want to know the process. We don't want to know the result. We don't focus on the result. What we do focus on is we focus on the process. So here it says +1. It's not +1, it's a +1. We're adding 1. That's what that means. We're going to add the 1. So when the question comes, 7 on the abacus, let me do something else. Let me go here. So we have 7 on the abacus, right? We have 7 on the abacus. That's what 7 looks like. And then we add the 1. We're not going to add the 1 here because then it would make it 17. We need to add the 1 by the ones place. So our number is, do we have enough? Do we have enough? Do we have enough to add? Can we do it? Yes, we can. We can add the 8. So we have, add the 1. So my final answer is 8 plus the 5. 5 plus 3 is equal to 8. Thank you. Thank you, Bubba. Thank you. Yes. And so you'll see that I go step by step and I increment the concepts, right? And so we kind of jumped ahead, but let me take it a step back and start showing you how to move the beads. Once we get comfortable about moving the beads, then we can go into understanding how the formulas work. And then we'll go into a 2-step, which is a little bit more advanced. So the next number is, right, 2. We want to add the 2. When we add the 2, we're not going to focus on the result. We all know what the result is, right? In life, we know what the result is. The result is that everybody dies. But what is the journey? That's the idea of life. That's the idea of abacus, right? We want to know what the journey is. And I don't know why in mainstream math, in elementary school, why we want the kids to focus on the result. Whereas in everywhere else in upper math, in complex math, we always talk about the journey, which is really strange, right? Like, they started changing the concept, like where the focus is. And I think that's what trips up the kids. Why do you focus on the result when we should be focusing on the actual process? So you focus on the concepts of how to make it, how to add. So my biggest question right now is, I'm so lost with the new ways. The new ways is trying to go into more understanding the idea of the concept of numbers. That's what they're trying to do. Oh my God, that makes sense. What? The problem just made sense? Okay. I don't know, but this is it for Danny.
Oh, I can see everything.
My question is always, do we have enough? If not, what can we do with it, right? So you always go back. So I have 6 on the abacus. I'm going to add the 2. When I add the 2, right, do I have enough? Yes, I have enough. So I'm going to add the 2. My final answer is 8. I don't focus on the 8. This is This is fun when you understand. Yes, yes, yes. And I know it gets really frustrating when the questions get a little bit more, right? But the idea is to slowly increment the concepts of reading the abacus and understanding it. And if you and those people that sit in, if they just kind of sat back a little bit instead of barging in saying 6 7 6 7 6 7, if you just sat back a little bit, I repeat the same thing over and over again. Can you explain 6 plus 6? In a little bit. Can we put a pin in that, Jay? Because that's like a little bit more advanced. But we'll put a pin in that. So we do 5 on the abacus, we put 3, right? 5 plus 3 is equal to 8. Guess what? You could do it on the dots, right? Just like the mainstream math. You could do it with the tally marks. That's fine too. Or but in the abacus world, right? We do it on the abacus. We do 5 plus 3 is equal to 8. Now, guess what? We can actually take it one step further. We can say 50 50 plus 30, 30. Now we got 80, 80. We can scale it, right? In mainstream world, you can't really scale it because that's a whole lot of dots, and I'm kind of lazy. You know what I mean? I get some pre-done questions for me because this is really, bleh. You could do that. Or you could do it through the abacus way and become scalable. This is why it's easier to see it on the abacus. It's representations. Every number is represented on the abacus. So we could even do it one more step further. We could do 500, 500 plus 300, 300. Goodness, it's like fractions and percentages. You could do fractions and percentages, but that's really just a concept. What we're doing in abacus world is we just do basic arithmetic. We can add, subtract, multiply, and divide. What's a fraction? Fraction is just a division. What's a percentages? Percentages is just times tables. Right? So we could do all of that, but it's just you have to understand the concepts. And what I'm trying to show you is I'm trying to show you the concepts on how to do it on the abacus. When we can visualize your numbers, it's one step closer to understanding. Oh yeah, exactly. Yes, thank you. So we have our next number, and then again, I have activities, right? This is meant for kids, right? They're supposed to be understanding. You add the two colors together, and then they give you a number, and then you color it in. There's my color by number. And then you add the 4. Adding the 4 just means you're going to go to the horizontal bar. If you're subtracting, you go away from the horizontal bar. That's the funny thing. So we're going to do some subtraction. Guess what? If you know how to add, you know how to subtract. What does that mean? If you know how to go to the horizontal bar, you're just doing the inverse, right? So we have 7 on the abacus. I want to take away 1. When I take away 1, I'm just going away from the horizontal bar. Thank you so much, Edric. Tapping is clapping. Oh, tapping is clapping. Yes. Thank you. Let's help her get to a bigger following and more funds. Oh, thank you. I would appreciate that. And we're already at 4,000. I'm very impressed. Thank you, everybody, for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
I realize I talk very fast. It's because I'm very passionate about the concept. But please, if I talk too fast, please let me know. Thank you, Sackboy, for the follow. So what we're doing is we're understanding that if you know how to add, you will know how to subtract. Thank you, Edric, so much for the roses. Edric. So when we're looking, we have our final answer is 6. Know that when you add, you go to the horizontal bar. When you subtract, you go away from the horizontal bar. Does that make sense? How are we doing? We could do it again with the 2, right? Same thing. We go to the horizontal bar to add. We added 3. 1, 2, 3. 1, 2, 3. We want to take away 2. Just take it away. We just do the inverse operation. That's what it is. If you know how to add, you know how to subtract. It's not a whole new strategy, right? It's the same strategy, but just reverse. Whereas in mainstream school, in public school, they give you all these different strategies to do things, like memorize your doubles. Is there memorize your doubles of minus? No, there isn't. Because if it's doubles minus, then you're just going to get 0 all the time, right? So it's different. In abacus world, if you know how to add, you know how to subtract. But that's, again, we're looking at the second number. When we look at the second number, it tells us whether or not we need to use formulas or not. So we have 4 on the abacus. We want to take away 3. 1, 2, 3. Right? Again, we go to the horizontal bar to add. We go away from the horizontal bar. And then we're going to go to adding of the 5. Adding of the 5. We have 3 on the abacus. We want to add the 5. Adding of the 5 goes to the horizontal bar. When we subtract, we go away from the horizontal bar. And so when we're looking, our final answer is 8. 5 plus 3 is 8. We go to the horizontal bar. That is what we're doing. So then we have 6. Notice what 6 is. 6 is 1 beat on top, 1 beat on bottom, right? That's what 6 is. But if I have 3 already on the abacus, how do I add 6? It's 1 beat on top, 1 beat on bottom. Thank you, Burly Boy. Thank you for the share. Thank you for the follow for Gizmo and Basket. So our final answer is 9. When we're looking at it, we're going to add the 6. When we add the 6, it's 1 beat on top, 1 beat on the bottom, and we add the 6. There we go. Thank you, Gert, for the follow. Same thing with the 7. 7 is 7, right? 1 beat on top, 2 beats on the bottom. But if I have 2 beads already on the abacus, I want to add the 7. To add the 7, it's 1 beat on top, 2 beats on the bottom, and you get 9. There we go. How are we doing? Make sense? We're all right? Thank you for the follow. Thank you for the follow. So again, guess what? We have 8. 8 is 1 beat on top, 3 beats on the bottom. But if we have 1 already, same thing. 1 beat on top, 3 beats on the bottom. It's not different. You will see that there's a number pattern. When you see the number pattern, you're going to know. That's why it's nice to be able to visualize your numbers, right? And if you know how to add, you know how to subtract. You just take away the 8, right? So if I have 9 and I want to take away 6, what is 6? 1 beat on top, 1 beat on bottom, and you take away the 6. That's it. I love how visual it is. I know, right? It's so crazy. You know, funny, you actually do the calculations in your head, but the fact that you could see it, you can know what you're doing. It's crazy. It's so crazy. I've been teaching abacus for 20 years, and it still baffles me like how easy it is. It's such a simple, easy to use tool, and I'm surprised that it's not as common as it should be, which is crazy. It's crazy because we have all these bricks, we have all these cubes. I don't know if you've seen these, but we have all these cubes. There's these counting bears, these counting dots. They have all these little things, but they don't have the abacus, and it's such a simple concept. Yeah. All right, we're gonna continue on. So we're done with this. Okay, we're done with this. What does that mean? Actually, we're not done. I have one more thing. Here we go. So in mainstream world in public school, somebody said that I read in a video or something that they had to memorize. We have to memorize how to make a 9. I'm like, why? Why do we have to memorize how to make a 9? On the abacus, we don't have to because we only go up to 9 anyways. So if I have 1 over here, I need to add the 8. Oh, look, I have 8. 5, 6, 7, 8. I have 8, right? Easy. We don't need to memorize how to make a 9 because it shows us on the abacus. If I have 2 on the abacus, I only need to add the 7. I have enough, that's all I got to do, just add the 7. I don't need to memorize it because there's no point. If I have 4 on the abacus, I'm going to add the 5. There we go. I take away the 5, add the 5. Oh, look. There's 9. So what we're trying to do is I'm trying to show you there's a lot of memorizations that happens in mainstream where you don't need to with the abacus because it's already there. Hello everybody. Hello. Thank you so much for the follow. Thank you user 5943 for the follow. Please, for those of you that just joined, please keep your mind open.
Now, open your mind to me, please. Open your mind.
Can you do square roots? Hello, Jaden. Hello, Jaden. Lance, can you do square roots? If you could show me square roots on a piece of paper, then you can do square roots. But if you can't show it to me on a piece of paper, that's more like memorization, right? Thank you, Anthony. I've always wanted to learn on the abacus. Thank you. You're welcome. You're welcome. You're welcome. You are very welcome. Yeah, people keep asking. It's like, one of them was like, can you do negatives? It's like, well, how do you do negatives on a piece of paper, right? How do you do negatives on a piece of paper? Let's start with that, right? What's an abacus? An abacus is a counting tool. It makes you just visualize your numbers. So on the square root thing, I don't know how to do square roots, right? How do you show this on a piece of paper? I know when you do 5 minus 8 and you want to do this as a negative, well, how do you show it on a piece of paper? You still got to do 8 minus 5, and then you have to remember that that's 3. You know what I mean? Same thing. If I have 8 on the abacus, take away the 5, that's 3. But if it's a negative number, I have to add my negative to it. So, I mean, that's the limitations. It doesn't do everything. It's not here to explain it's not here to explain the universe of math. It's just here to show you what the numbers are. Bragging rights. You know what I mean? Does that make sense, Lance? Like it doesn't make sense to show this. It's a physical tool. How do you show square roots with cubes? If you can tell me that, then I can show you on the abacus. You know what I mean? So if you can get these cubes to show me how an abacus, how the cubes look in a square root, then I can show you on the abacus. So, yeah, I mean, people come around and ask me these questions, like, but if you can show it to me on a piece of paper, then I can show it to you on the abacus. Because what does the abacus do? It just shows you the numbers. You're just visualizing your numbers, really. Okay, so we're going to continue on. Okay, we're done with that. We're done with that. We're done with that. Okay, well, let's do a little review for those people that just joined. Thank you, everybody, for joining. Thank you, everybody, for joining. We're learning how to use the abacus. An abacus is a math tool that visualizes your numbers. That's all it is. It just helps you visualize your numbers. What about a maze? Oh, you want to do a maze? Okay, let's do a maze. We will do, you know what? We'll do a 4-digit maze. We'll do a 4-digit maze. Thank you, Bubba. We could do a 4-digit maze. Maze. Okay, so, hello, Abdul. Okay, we are here. We have this number. If I look at my number, there we go. We have our number. What number do we have? We have our ones, our tens, our hundreds, our thousands. What number do we think that is? An abacus is a counting tool. Every time the top bead is anytime the beads are touching this horizontal bar, it is considered counted. So when we're looking, right, these are counted, and then this is a placeholder, right? This is a 0. All the bottom beads is a value of 1. So if this is 1, and then these are 4 ones, 1, 1, 1, 1, and then the top bead is a value of 5. But the top bead is not touching the horizontal bar, so it's not being counted. So this would be 4, and this would be 9. This is 9 because, almost, Bubba, this is 900 because the top bead is a value of 5. So 5 plus 4 is equal to 9. 5 plus 4 is equal to 9. We have another 4 right here. If I add this 5, then we would have 9. This would be 9,909. But instead, we actually have 4. So it's actually 9,401. That's what that would be. So don't forget we have the comma. Thank you so much for the comma. The comma would be this, right? So if you look, there's a dot right here. That's a label to tell me that that's the thousands. And so, that's not right. There we go. So the answer is 9,400. So we have our next number. What number do we have here? So we have the top bead is a value of 5. Excuse me. We have the top bead is a value of 5, and we have the bottom bead is a value of 1. So when we're looking, what number do you think this is? So wait, why are you starting the second row? That's a really good question. I started in the second row because I have a dot right here. Do you see that little dot right there? That dot tells me that this is my ones place. And I'm trying to find oh, here it is. So when I look, I have my ones, my tens, my hundreds, my thousands. That's why, because I have a label right here. This label tells me it's the ones place. After the ones would be my tenths and then my hundreds. So when we're looking, it is our decimal right there. Hello, Damien. Hello. I think JS just got it. Yes, JS did get it. It is 8,830. Not 1. It's 6. Hot durian. Welcome.
Now, open your mind to me, please. Open your mind.
It's pretty easy once you count. Heck yeah! It's pretty easy when you could see everything.
Oh, I can see everything.
It is not 88. It is 8,836. That's what it is. After school. What the? This is what? It is this. It's after school. I don't wanna deal with this. DJ Tickle. You didn't have to come to my live. You do know, right? Like you can swipe. You can use your thumb and swipe. Did you want me to tell you how to use TikTok? You could swipe, right? Keep scrolling. Keep scrolling. Keep scrolling. You don't need to be here. Keep scrolling. Haters gotta hate. Apparently DJ Tickle doesn't know how to swipe. Yeah, scrolling? Do you know what doom scrolling? Being smart is always worth it. He needs a mind.
No, now go away or I shall taunt you a second time.
Bubba, do you know where that one came from? How about this one?
I have come here to chew bubblegum and kick ass. And I'm all out of bubblegum.
I am all out of bubblegum. Rage bait! Oh my god! DJ! You don't have the talent to rage bait. I'm sorry. Right? I'm telling you. Rage bait. Oh, you think you're so good. Aw, you're so cute. All right, here we go. So we have our next number. Our next number is our ones, our tens, our hundreds, and our thousands. We have our thousands, we have our hundreds, we have our tens, and we have our ones. What number do we think that is? Womp, womp, womp. He stopped the learning. Ah. Nah, he didn't stop the learning. I just like to be... Yes, so it's 1,460, right? Because the top beat is a value of 5 and the bottom beat a value of 1. So when we're looking, we have a 1, 1, 1, 1, 1. So these are all 1. So when the beats are counted, they're touching the horizontal bar, right? Why can't I do it? Why can't you do what? You got it. 1,463. What's wrong? No, you got it. So we have 1,463. And we're going to continue on. We have 1,000. We have our thousands, our hundreds, our tens, and our ones. Oh, can't see that. Sorry. So what number do we have? What number do we have? Thank you. Thank you, Kurt. Yes. So it is 1,726. Well done. So what do we remember? We remember that the top is a value of 5. So we have 5 here and 5 here. This is not counted, so this is not being counted. So it's not part of the number. So we have 1,000. This is the 1, but and the top beat is not touching. We have the 2 here, and then the top beat is not. The top beat is touching. So this is actually 7. So we have 1,726. Thank you, Anthony. Oh, you're not that fast? Don't worry about being fast. Worry about being correct, right? The idea is understanding. The idea is not to be fast. The idea is to understand what we're reading. I'm not here to have a competition. So we have our next one. We have, oh my gosh.
Sorry, I didn't quite catch that.
Okay, so we have our next number. What number do we have? We have our ones. We have our ones, we have our tens, we have our thousands, and we have our hundred. No, we have our hundreds and we have our thousands. This is like Greek mythology that you're able to teach. 5,876. Hello, Casa. Hello, Casa. How are you doing? Yes, thank you. It is 5,876. Well done, well done, well done. it's around Mesopotamia. That's when it came about, and then it was reinvented. It was reestablished with the Chinese one. There's a Chinese abacus, and then it got reinvented again in Japan. And in 16th century, it was 16th century it was reimagined. So 16th century Japan came around and made it more efficient, and that's what we use now. There's not too many people, I don't know how many people who know how to use the Chinese abacus, but the Japanese abacus is what's being taught, and this is the more modern one. I'm trying to put the baby to sleep. Yeah. So the difference between the two is that the Japanese actually came up with using complementary numbers. The complementary numbers are right here. And so when we understand how to make a 5, and we're going to understand how to make a 10, and then you'll be able, is this helpful for young kids, or do you have to experience, I'm sorry. Is this helpful for young kids? Yes, it is. Do you have experience with teaching kids using this? Yes, I do. I have been teaching abacus for 20 years. This is not just a flyby thing. These are all my books that we're looking at, and I've taken the time to put my brain into these pages. So yes, I have taught many, many children. And I still have classes now. I have a few students right now that I'm trying to do. Yeah, thank you. I don't know, 08. Yeah. And so when we're looking, right, we have our number, we have 1000s, and now what I've been doing is I've been teaching adults because there's a lot of adults that want to keep their brain active. The reason why is because what I want to do is I want to introduce this to also provide brain gymnastics. So the idea was to keep our brain active to try to deter dementia and Alzheimer's. So just like we were told, you need to use your brain, you need to do Sudoku, you need to do crossword puzzles and jigsaw puzzles and so forth. Well, you can also do abacus as well. The other thing is you could go live and try to cook trolls. I like to cook trolls because that keeps my brain active. You know what I mean? So it wasn't rage baiting. It's just trying to keep up with my toes. It could just keep you on my toes because I've been doing this for so long. It's been easy for me to do, and that's why I talk really fast, because I'm really passionate about it. But I also know I talk really fast, and I need to slow down a little bit. I wish I had that talent like that. No, you will if you spent 20 years doing it. I'm actually learning from you. Oh, thank you. You help me understand from your perspective. Oh, thank you. Yes, I do appreciate it. And I think it's the greatest thing. Because you can visualize your number. Once you visualize your number, you'll be able to understand what you need to do to add, subtract, multiply, and divide. And there's a lot of people that are haters. You're right. There are haters, which is fine. I'm not here to be like, oh, this is everything. It's not. This is not geometry, it's not trigonometry, it's not algebra, it's not calculus, right? Those are specific math things. What this is the gateway to more complex math. What I'm giving you is a foundation of how to add, subtract, multiply, and divide. Once you do that, you understand the foundation, then you have room in your brain to know higher math. You know what I mean? So our answer is 9,749. Well done, Jay. Well done. I hate math with a passion. That's fine. What would be harder, geometry, algebra, and trigonometry? Calculus? Jay got it. Yeah, Jay got it. Jay Sturdy got it. Is calculation a muscle in a brain? Yes, it is. It's just like it's a synapse, right? And so what we do is, what I notice is the people that have come in my lives, then they're a little bit older, they notice that they're starting to be a little bit slower in their thinking. Like they can't grab their words like they used to. But when they started to do abacus, they're starting to find their words quicker. So when we're looking at it, it's all about just keeping the brain active and trying to do things. What grade? I don't know. I think grade 9. So what would you recommend to start with the first grader? I would recommend a maze book. So you can either start with a 2-digit maze, or you can start with a 3-digit maze. It all depends on how many digits they know. So you could start with the maze books. Exactly what we're doing here. Right? Exactly what we're doing here, but with less numbers. So this is the maze books right here. And then what I have is the mazes. This is a 2-digit number, right? We did 2-digit number at the beginning, and then there's a 3-digit. If your child is a little bit more advanced, maybe you do a 3-digit number, right? Get them comfortable with looking at 3 digits. And there's a variation between, there should be a variation, but, it's a little bit tougher. Yeah. So I do have books available in my TikTok shop. Yes, thank you, Bubba. I have this one. Okay, or there's a package. So the package is there's the mazes that you can get, and then I have a whole set. So what we could do is the whole set is a first grade set, and what they will do is this one. Not they don't come with this. It comes with the two mazes. So you do the a 2-digit maze, a 3-digit maze, and then you have adding of the 5, minusing the 5. If you know how to add, you might know how to minus. If you know how to add a 10, you will know how to take away the 10, and that's it. How can I help myself with SATs? You know, if you want somebody, I have somebody. I think she helps you with SATs. You can DM me and I can send you who it is, but I don't do SATs. All I do is basic arithmetic. So, what if you needed to subtract? That's what we're going to get into. Thank you, Jaden. Yes. So the muscles in the brain, geometry, trigonometry. Okay. So that's what we're going to do. We're finish off like with the maze. So this is the maze, and let me do a little review of what the maze looks like. Again, this is a 4-digit maze. The 4-digit maze talks about the thousands, the hundreds, the tens, and the ones. And what we're doing is I give you like an explanation of how to read the abacus. We have our single digit, we have our double digits, right? I do a little review on what the double digit is, and then after that we do the triple digits. And then after that I give you a little bit of the 4 digits, right, on how to read it, and I give you a review. So we have like these little things, and then after that I give you the mask maze. The mask maze is meant to cover the maze because you can see the numbers, you can see the answers on the path. So the idea is to use the mask maze. However, the paper is a little thin. I give you the opportunity to download the paper so you can put it on a thicker piece of paper like that. And so when we're looking at it, it would be like that. Does that make sense? So, and then we have our, so what it looks like without color, it would look like this. And so it's up to you to figure out what the number is. That's what this is. And then we have this. We have the reverse maze. A reverse maze means that I give you the path, and it is up to you to fill in the abacus. That's what that is. And then I do have answers in the back of the book. That is a 4-digit maze. I don't know if your child is ready for 4-digit. You could get the 4-digit. It's up to you, but it's not part of the first grade bundle. So what we're going to do now, since we've already done adding, and we're going to understand how to make a 5. That's one of the core concepts. One of the core concepts is how to make a 5. Cool. So this is what we're going to do. We've already done what happens when there's enough. And we're going to continue on. Thank you, everybody, for joining. This is going to be super simple, but don't forget, we're not going to memorize. We're not going to memorize how to make, we're not going to memorize 4 plus 4. What we're going to memorize is we're going to figure out how to add a 4. We're not going to count up. So in mainstream math, they do a lot of counting up, but in Abacus world, we don't count up. What we do is we do a concept of how to make a 5. Right? How to make a 5. When we make a 5, 1, 2, 3, 4, 5, 6, 7, 8. There we go. Let me show you one way. One way is, I have 4 on the abacus. Let's see which way looks better for you guys. I have 4 on the abacus, right? 1, 2, 3, 4. Right? 1, 2, 3, 4. There's 4. 1, 2, 3, 4. And then we have 4 again. Well, guess what? There's not enough room to add the 4. We don't want to add 4 here. We're not going to add 4 here. What we're going to do, because what would that be? This would be 44, right? The idea here is 44. But that's not what we want. We want to add 4 in the ones place. To add 4 in the ones place, we're not going to count up. What we're going to do is we're going to utilize this concept. The concept is how to make a 5. We're going to round up to 5. What does that mean? Well, if I have a 5, it's more than enough to make a 4, but that's too much, so I have to take away the 1. So when I take away the 1, my final answer is 8. 5, 6, 7, 8. I add the 5, I take away the 1. My final answer is 8. So you have to add in order to subtract.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
So what we're doing is what? We need to subtract in order to add, right? We need to make room. Before we add what we need, we got to make room. Let's do it again. Let's try a different way. So I have 4 on the abacus. Let's see, I have 4 on the abacus. There's my 4. I want to add another 4. I want to add another 4. So I have 4 here, and I have 4 here. I have 4 here. Now guess what? If I want to add a 4, I need to round this up to 5. If I round this up to 5, because I know how to make it, right? There's no more room to add it. But if I round this up to 5, I need to get a 1. The 1 has to come from somewhere. If the 1 comes from somewhere, where does it come from? It has to come from the previous number. It comes from the 4. So I have to take away 1 from the 4. So I take away 1 from the 4. And then what happens? I can add it back to here, and now I've made a 5. I just made a 5, and so all I gotta do is just add the 5. And then that's it. So again, what we did is we subtract in order to add. We had to subtract in order to add. Just like we have to drift, right? When we drift, if we're going too hard to the right, we got to turn left.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
So we could do it again. This concept can be scalable, right? So when we're looking, we have this number here. We have 3 on the abacus, and I want to add 4. If I have 4, what do? It's the same thing. If I want to make a 4. Notice we don't focus on the result. We focus on the second number. We focus on the process. When we look at the process, that is what dictates whether or not we use the formula. Do we have enough to add the 4? No. So how do we do it? Well, let's say we can actually move this to make a 5. Round this to a 5. To do that, I got to take 1 from the 3, add it to the 4. This makes a 5. That makes a 5. So my final answer is 7. And that's it. So what we're doing is we're understanding how to regroup at a smaller scale. We regroup already at a bigger scale with the 10. But this is a very small concept, and then we start incrementing our way up and up and up. But we got to compound our knowledge. Before we start going into all these other questions that we have, understand the fundamentals. Once you understand the fundamentals, then it's easier to compound our information. Does that make sense? So when we're looking, we can do it again. We have 2 on the abacus, and I have 4. We have 4. When we have 4, what are we going to do? 2 on the abacus. We want to add 4. I cannot add 4. There's not enough. What do? Well, we have, excuse me. We have 4 here. All we got to do is take away 1 from the 4, from the 2. Add it to my 4. Take away 1. Add the 5. So my final answer is 6. That's all I did. That's all I did. Okay, for those of you that just joined, and if you could do me a favor, I'm going to take a little break, and we're going to do a little bit of a tapping spree. So for those of you that are interested, and those, if you liked my content, if you could help me out, please provide a little tapping spree. And I'm going to play some music. No, if we could get up to like 10,000, it would be really great. If we could get up to a 10,000, I would love it if you guys can tap it out. If you can do a double tap for me, that would be lovely. Thank you. And I'm going to take just a little break. Thank you so much, everybody. Thank you so much. Okay, thank you everybody for trying to tap it out, and we will continue on. For those of you that are interested, what we're doing is we're just learning how to read the abacus. After we learn how to read the abacus, we go into adding, subtracting, and multiplying and dividing. But we'll see how far we can get. Thank you everybody for joining. Thank you everybody for joining. Please keep your mind open for something different.
Now, open your mind to me, please. Open your mind.
I am here to show the matrix what an abacus is. Thank you everybody and welcome. Welcome.
Welcome to the real world.
All right, so how are we doing? Okay, so for those of you that are continuing, or for those of you that are still here and they started with me when we were talking about adding and subtracting, we're going to continue on. If I had 4 on the abacus, right? If I had 4 on the abacus, I want to add 3. Well, guess what? When I add 3, what do? I can make a 5. Right? I don't want to add it to here. This would be 1, 2, 3. This would be 34. But what happens is, if I would need to make a 5, how do I do that? To make a 5, I need to get a 2. 3 plus 2 is equal to 5. Now what? 3 plus 2 is equal to 5. Where am I going to get the 2 from? I'm going to get the 2 from the 4. There's enough beads to take from the 4. So I have to take away the 2 from the 4, like that. And I add it to my 3. All I did was I regrouped. When I regrouped, I made a 5. So I can add my 5 to show it. So my final answer is 7. There we are. Hello everybody, hello. Thank you so much for joining. How are we doing? Or are we all right? So we can continue on, and then we could do it again. If I have 3 on the abacus, and I have 3 over here, I have to add another 3. Notice I have no more room to add a 3, so what do? I need to make a 5 out of this. I'm going to round up. When I round up, what do? I need to get 2 from somewhere. 2 has to come from somewhere. 2 will come from the previous number. The previous number will be here. So I take away the 2 from here, and I add it to make a 5. So I just made a 5. So my final answer is 6. There we go. How are we doing? We all right? Whew. 70 people learning in the middle of the night. Are we all right? Too much? Should we review? Let's do a little review for those of you for the newcomers that just came in. So we're going to add on we're just going to count on the abacus. An abacus is a counting tool. It visualizes our numbers. So we have 1, 2, 3, 4, and then we have 5. The value of 5, and then we have 6. We have 7, 8, 9, and then there's 10. 10 is a 1 and a 0. And then what we can do is we can actually look at every column. Every column has a number. We have our ones, our tens, hundreds, thousands, and 10,000s. If you notice, there is a dot right here. This dot tells me is my ones place. This ones place is right here. So that means there's a decimal, and after the decimal is our tenths and our hundreds. Thank you everybody for joining. Thank you everybody for joining. My name is Lynette, and I'm here to explain what an abacus is. I've been teaching abacus for about 20 years. Does the bigger the number go with bigger numbers? Does the bigger one go with bigger numbers? Well, if you need more numbers, then you get a bigger abacus. But you could still use small numbers on the bigger abacus. This is a 13-column abacus, and this is a 7-column abacus. If you use the bigger abacus because size matters, you just have more numbers. I would use this one. I would use the 13-column one when I do division because I need the extra columns to help me track my numbers. You may not necessarily need to, but it works exactly the same. See how there's these dots, right? There's these dots. These dots are just the same thing as the labels. You can choose any one of these dots to be your ones place. You can be here, so it'd be ones, thousands, and then millions. Or you could be this one over here, ones, thousands, millions, and billions. Or we could do this one over here, ones, thousands, millions, billions, and then trillions. And there we go. And so when we're looking, right, this is what a 13-column abacus is. And then we could do, So it just depends on how big the number is. Usually for the beginning parts, I would probably start with the colorful abacus because it's pretty. and then I would graduate to the bigger abacus. But if you don't want to have all the extra, if you don't want to have extra abacus, then I would go straight into a 13 column abacus. I didn't learn from these ones. I actually learned from a 23 column abacus. This is my personal abacus, and it is 23 columns. It is a little bit bigger. Oops, it is a little bit bigger than this one, right? This is what we had like 20 years ago. Now we have a variety of it. So that's the comparison, right? And so when we're looking at what is this? This is my iPhone 12. Oh, here we go. My iPhone 12, or it's this abacus is like the size of a cassette case. Yeah, kinda, right? That's how compact this is. I'm gonna do a post on that. So, yeah. So this one was a cassette case. For those of you that don't know what this is where we used to listen to our music. Yeah. So it's so that's why it's kind of nice. It's kind of nice and compact. Whereas the 13 one's a little bit bigger. It's probably twice the size of a compact case. Yep. There we go. There we go. So that's my little prop that I got. All right. How are we doing? Okay. I think I'm about spent. Oh. So for those of you that are still here, this is what we call a Chinese abacus. A Chinese abacus is 5 beads on top, 5 beads on the bottom, and 2 beads on top, which is very similar to the Japanese abacus. But we have what? We have our ones. We have one. Oh, sorry. We have 1, 2, 3, 4, 5, and then because we have 5 here, we're going to add the 5 here, right? We're going to do a trade-in. We have 5, and then we trade that into this 5. So we have 5, and we have 6, 7, 8, 9, and then 10. So we have 5 here, we're going to trade it into here. After we have this, we're going to trade it again from here to here. So we have 10. So notice that this is 10, and this is 10, but then this is also 10. So you do a lot of trading. Whereas but then what happened is the Japanese came around and said, we're going to make it more efficient. Because we can make it more efficient, that's where they started understanding the concepts of how to make a 5 and how to make a 10, which is a very interesting concept because once you know how to do this, it's so easy to be able to add and subtract. But the idea is to understand these fundamentals. Thank you, Edric. Thank you, Edric, so much for the roses. Thank you so much for the roses. So what we're doing is we're going to count 1, 2, 3, 4, right? And then 5. The top is a value of 5, and then we have 6, 7, 8, 9, and then 10. There we go. So when we're looking, we have our 1 and a 0. We have our 0 and our 1. So this is 10, this is 10. But the difference is, in the Japanese abacus has markers, right? And they kind of help you with these markers and labels. But the Chinese one doesn't. You kind of have to make your own. Yeah. So that's about it. Now we can do some more. You might be wondering, where else have you seen an abacus? Oh, you know what? Let me do that. Let's do a little field trip. Let's do a little field trip. For those of you that are like, you know what? I don't know. We've seen them somewhere. I'm like, yes, you have. You've seen them everywhere. Let me see if I can find it. Hold, please. There it is. Oops. Okay. So, here we go. Oops, wrong one. Okay. Cool. That one, this one. There we go. So abacus is actually quite everywhere. It's really crazy. Really, really crazy. Have you ever seen a movie called Wonka? Anybody seen the movie called Wonka? Wonka, there is a character. His name is Abacus Crunch. Hello, Ennis. Hello, movies and museums. I know, right? Movies and museums. His name is Abacus Crunch. What are we doing? Oh, wait, hold on. We are...
Gee, babe, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
Ah, thank you, Edric. Thank you so much for all the roses. I appreciate that. I appreciate that. The next one is in Madagascar. The penguins of Madagascar. Kowalski actually upchucks an abacus. This is a Chinese abacus that he upchucks. Very interesting. In Seoul, they also try to keep track of souls on the abacus. If you ever seen Fairy Mary, the Tinkerbell movies, excuse me, Fairy Mary counts on the abacus. In Mulan, the ancestors count on an abacus. Now, for those of you that are here, what number do you think that is? What number do you think that is? We know these numbers. We have how many digits are they using? Right? If there's 1 here, 2, 3, 4, 5. Hello, Deceptive! Hello, Deceptive. How are you today? Guess what we're doing today?
Gee, Ray, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
What number do we think this is? Come on. We all went through it. What number do we think this is? Yes. 8,000. 87,000. 661. I don't think there's a decimal. They didn't deal with decimals back in the day. Next is, you forgot the 1 right here. Yeah, so it's 8,000, 5, 6, 7, 8. I don't know if you can see that. Yeah, there we go. Yeah. Yeah, sorry. The Chinese one doesn't have an indicator. Okay. So, thank you everybody. In Powerpuff Girls, there was an episode, Him Diddle Riddle, episode 4, season 4. Blossom does some calculations on the abacus. There's a book. Her name is Hannah, and she is she's blind. But the parents still want her to learn. So they actually made an abacus out of acorns. Alright, this is the last bit. I don't know if anybody ever played Empires and Puzzles. There's a character that actually uses a pulverizing abacus, which is kind of strange. I don't know why you would want to use a pulverizing abacus, but it is there. Then if you ever played Dragon Quest 3, there is the Seeds of Salvation. There's the Abracadabra Abacus. In Match Factory, there is an abacus in here. And there we go. Yes, Bubba. Raise his hand. Is there a question? So we can continue on. Here are some of the other things, right? You know that there's abacus here. So what are the type of abacus that we have? I showed you 2. I teach from the Soroban. This is a Target abacus. I don't know why they did a 11-bead abacus, but they did 11-bead. There's an IKEA one that's very similar to a Melissa and Doug abacus, and there's an IKEA one. This is a Russian abacus. This is a Kramer abacus. A Kramer abacus is meant for people who are blind, and the difference between it is that it's a little bit stiffer to move. This one is very easy to move, but yeah. And then this one is a Dutch abacus. It's called a Reckonrec, and then this one's called a Coder abacus, which is probably from Right Start. I don't know how they do it either, but I don't know how to do these abacus. It's kind of similar, like there's a 1-to-1, but other than that, that's as all as I know. So that's it for me, and I'm about spent. Thank you everybody for joining. Thank you everybody for joining. Ooh. Hello. Hold on. That wasn't right. I wanted this one. There we go. So, I hope that was okay for everybody and everybody was able to understand. Thank you, Hockey. Thank you so much for the... What? Thank you for the perfume. Thank you, Bubba. No, thank you for your time. Thank you for your time and your comments. I'm happy to entertain and be able to tick that off on your, what is it? On your bucket list of 2025 on how to read the Abacus. Thank you. So, what we're doing to do, yeah, I'm about spent. I'm about to head out. Thank you, everybody. Thank you so much for joining. Thank you again. Have a good night. Have a good day. Have a good morning. If I don't see you again, what is it? Where is it? Hold on. I have my little thing. Where is? I have this one.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
Thank you. Thank you, everybody. Thank you so much for joining. And I hope to see you in my next live. Bubba. Yeah, it's like memory lane, right? Like all these little sound bites. I have a lot of sound bites. I don't use any of the default ones. So. Thank you, Hockey, for the perfume. It's so good. Thank you so much. I've been practicing. All right. How are we doing? Have a good night. Have a good day. Have a good morning. Thank you, everybody. Bye.